So problem 23.19 is asking us about two 2 centimeter diameter insulating spheres which have a 5.20 centimeter space between them. One of the spheres is charged to 55 nanocoulombs and the other is negative 31 nanocoulombs. What's the electric field strength at the midpoint between the two spheres? So you can see that at that midpoint, if they have a diameter of 2 centimeters and a distance of 5.2, that midpoint is going to be about 3.6 centimeters in between the two spheres, which becomes important with our electric field of a sphere equation, because the R value in that equation is always going to be from the center of that sphere to the distance, not from the edge of the sphere or anything like that. Another thing to note before we start solving is that for a situation like this in which we have a positive and a negative, and we're looking at a point in between them, the electric field is going to be directed towards the negative sphere. And you can think about these spheres kind of like point charges in how you think about that. But it's essentially focusing on the idea that a positive thing, the electric field points outwards, and a negative thing, electric field points inwards towards the center. So with that in mind, we're going to be able to use our E-sphere equation, which is very similar to Coulomb's law, that equation, in order to solve for that midpoint. So to do this, the strategy is essentially going to be to solve for the individual charges and then add them. And that's that same idea that I was talking about earlier, because the electric fields are pointed in the same direction, they're going to be able to just add together. So at that midpoint, we can solve for both of them and then add them. For E1, which is that 55 nanocoulomb, I just plugged it right into the E-sphere equation, always keeping in mind that you need to put everything into the right unit form. And once you do that, you get a value of 3.82 times 10 to the 5th newtons per coulomb. And then for the negative 31 nanocoulomb, did the same thing. I mostly just focus on the magnitude of these here. But nevertheless, the 31 nanocoulomb, it's the exact same equation essentially, except for a different charge. And when you plug that in, you get 2.15 times 10 to the 5th nanocoulomb. Or not nano, newton per coulomb. So the last thing that you have to do here is just add them together. And once you do that, you get a total electric field at that midpoint of 5.97 times 10 to the 5th newton per coulomb. So that is that electric field. Once again, like I said, the electric field is going to be pointed towards the negative sphere. And that's pretty much it. This problem's not too bad. It's pretty simple. I think maybe you can make a mistake by seeing that they tell you that the spheres are 5.2 centimeters away, and you forget to account for the radiuses of the spheres. But other than that, as long as you remember to convert your units, it shouldn't be too bad. Thank you for listening.